Identity number 1. We have cosecant of x over 1 plus cosecant of x minus 1 over sine of x minus 1. That is equal to 2 secant square of x. First, what we need to do is convert the first fraction by reciprocal identities. That would turn the cosecant of x into 1 over sine of x, and this would be over 1 plus cosecant of x over 1. We multiply this and we would get 1 over sine of x plus 1. If we subtract this from 1 over sine of x minus 1, this would be equal to the two first fractions that we got. Then, we can get common denominator out of this. So, if we multiply this, we will get sine of x minus 1 minus sine of x plus 1. Over sine of x plus 1 times sine of x minus 1. If we multiply and eliminate the parentheses here, the result would be sine of x minus 1 minus sine of x minus 1. Over sine of x plus 1 times sine of x minus 1. When we get this, we can cancel out both signs. That would give us minus 2 over sine of x minus 1 times sine of x plus 1. This denominator can be further simplified. So if we multiply this, the result will be sine the square of x minus sine of x plus sine of x minus 1. We cancel out both signs, we get that the result is sine the square of x minus 1. When we get this, the new operation would be minus 2 over sine the square of x minus 1. This denominator can be converted using Pythagorean trigonometric identities, and that would give us that it is also cosine the square of x. We can cancel out both negative properties, and that would give us 2 over cosine the square of x. This can be converted using reciprocal identities, so that would be 2 second the square of x, and that would be our final result. Identity number 2. We have tangent of x minus cotangent of x over 1 minus 2 cosine the square of x, that is equal to tangent of x plus cotangent of x. First, we need to convert tangent and cotangent through quotient identities. This would turn the tangent into sine over cosine, and the cotangent into cosine over sine. After we have done this and we have two fractions, we can now get the common denominator and join them. So that will leave cosine 2x over cosine x sine times sine x. Cosine 2x over 1 times 1 over cosine of x times 1 over sine of x. And using reciprocal identities, we can simplify this into cosine of 2x times secant of x times cosecant of x. The divisor of the original equation, we can convert it into minus cosine of 2x. When we join this and we get the common fraction of minus cosine of 2x times secant of x times cosecant of x, over cosine of 2x, get that the final answer is secant of x times cosecant of x, as both cosines will cancel each other. Identity number 28. Initially you have tangent square of x times cosine square of x plus cosine square of x equals to 1 over cosecant square of x plus 1 over secant square of x. What we need to do first is convert the tangent square of x by using quotient identities. This would turn into sine square of x over cosine square of x. This will be multiplying the cosine square of x and this would leave us with a fraction. But when we do this fraction, we can notice that both cosines can be cancelled. So we do this, and then on the other side of the equation, we can use reciprocal identities. And this would leave us that 1 over cosecant square of x is equal to sine square of x, and 1 over secant square of x is cosecant to the square of x. And then if we join both sides of the equation, we can know that the final one would be sine square of x plus cosine square of x is equal to 1, and that would be the final equation. Identity number 30. We have 1 plus sine of alpha times 1 plus sine of minus alpha, that is equal to cosine to the square of alpha. Let's say alpha is equal to x, so that will leave us with 1 plus sine of x times 1 plus sine of minus x equals cosine square of x. The first step that we need to take is multiply the second parenthesis, so that will leave us with minus sine of x. Then we should multiply both parentheses, and that will leave us with the answer of 1 minus sine of x plus sine of x minus sine to the square of x. If we simplify this and cancel out both signs, would leave us with 1 minus sine to the square of x. And using Pythagorean trigonometric identities, we can know that this can be further simplified. And that would turn into cosine to the square of x. And that would be our final answer.